So now we want to consider finding the solutions to the equation sine of x is equal to half. Now, the way we've done it before is we've looked at restricting our domain. So if we've got our solutions between 0 and 2 pi, then we'll find our related angle, which is pi on 6. Sine's positive in the first two quadrants, so we get pi on 6 and 5 pi on 6. So we know that's going to be our answers there in the first two quadrants, if it's only one revolution. What if the domain is unrestricted though? What if we don't have that 0 to 2 pi restriction? What will we get our solutions? Well, of course we'd have pi on 6 and 5 pi on 6. But then what if we go on next revolution? 13 pi on 6, 17 pi on 6. So there's the second revolution. And then add another 2 pi to each of these two solutions. We're in the third revolution. What about if we subtracted 2 pi and went backwards? We could go that way as well. And we could see that we go on forever in both directions. We have an infinite number of solutions to that equation if we don't restrict our domain. But that's a little bit hard to write. How can we write a little bit easier? So the idea is what we want is to find a pattern there and get this, what we call a general solution. So we know that our related angle is pi on 6 because inverse sine of x is a half. In the first quadrant it's pi on 6. That's our related angle. So we know all our solutions are in these positions. So it's pi on 6 away from our positive x-axis and pi on 6 away from our negative x-axis there. So if that's the case, then what we're going to have to do is come up with a way to describe our pattern. But now when we're on the positive x-axis, we want to add pi on 6, but when we're on the negative x-axis, we want to subtract pi on 6. So what we want to do there is say, well, we know we want to go to each and every axis. So as we've said in the previous video, that the solution in this one here, we would have to go to each axis. So n times pi would mean we go to each axis there. So when n's 0, we're there. When n's 1, we're there. When n's 2, we're there. 3, and so on. Same in the negative direction. But this time, what we want to do is, if we're on the positive axis, we want to add. But on the negative axis, we want to subtract. So if n's going to be positive, if n's going to be an even number, we're just going to add it. So we'd say there, what we want to do is have this idea that if n's a even number, putting minus 1 to the power of n would make it a positive number. And what we want to do is then multiply that by pi on 6, because we're going to add pi on 6. But if we're going to have n being negative, being even odd, that would give minus 1 to the power of an odd number a negative answer. So when n's odd, that's on the negative x-axis, and then we'd subtract pi on 6. We'd go back there. So there's our little trick here with sine. This is the hardest one out of sine, cos, and tan in the general solutions, because you have this idea that it's going to change sine here and add it times and add it sometimes, subtract it sometimes. But it all depends on whether n is an odd number or an even number. Remember, n's going to be an integral number, so n's going to be integral. So when it's positive, when it's an even number, we get it that part on the positive x-axis, and then we're going to add pi on 6. And when n's odd, we're going to subtract, because n's going to be odd there, so it's going to be a negative. We're going to subtract pi on 6 from whatever we have on the negative x-axis. So in general, if an answer is sine x is equal to a, then we get this situation, as we said. N times pi puts us on the positive x-axis, then the negative x-axis, positive, negative. And when n's even, that makes that part positive, so we'd add our angle, inverse sine of a. And if it's odd, that puts us on the negative x-axis, and that would give us a subtraction of that angle to go back to pi, go back into the second quadrant there. So a little bit tricky, but have a look and see how they work with some questions later on.